Another principle I want to bring up here is how math and math-adjacent fields tend to reward you when you respect their symmetries. And in this case, we already know that pi is going to be somehow relevant to the answer, and pi has everything to do with circles, relating distances around the circumference of that circle to the radius. So on our hunt for pi, it's tantalizingly close to be working with an ellipse like this, and you might feel like it would be all the more natural and maybe more promising if this was instead a circle. Now we can actually make this into a circle just by changing what the coordinates of that state space represent. Here's what I mean by that. The equation for a circle looks like x squared plus y squared equals some constant without any numbers sitting in front of those variables. If I let x not represent v1, but I let it represent the square root of m1 times v1, then x squared gives us something that looks like 2 times the kinetic energy. And similarly, if y represents the square root of m2 times v2, that y coordinate also more directly captures the energy of the little block. And this equation for the circle, x squared plus y squared equals some constant, now captures the conservation of energy, but in this rescaled coordinate system. Like I said, the hope is that adding a little more symmetry will make our problem easier to solve. And in a moment, you'll see how this is true. Let's take a minute to get a little familiar with what this diagram is really telling us. For example, at the very beginning, that big block has a negative velocity, so we must be somewhere on this left half of the plane. And that little block starts off stationary, meaning the y-coordinate is 0, and so we have to start out at the leftmost point of this circle. That's the initial condition. Now, after they collide with each other, what happens? Where do we end up? Well, physical intuition tells us that that little block picks up some kind of negative velocity, so we're going to have to end up somewhere where the y-coordinate is negative, and that big block loses some of its momentum. So the x-coordinate is going to get a little closer to 0 from where it was, even if you don't know exactly how much. And again, we have to stay somewhere on this circle. The circle represents all the points that have the same total energy, and so you might guess that our point lands somewhere on like this arc right here,